today's LeetCode DCC question is cheapest flights within K stops. Let's read the question. There are n cities connected by some number of flights. You are given an array flights where flights I says from to price, indicating that there is a flight from city from to city to, and the cost of the flight is price I. You are also given three integers: source, destination, K. Return the cheapest price from source to destination with at most K stops. Remember, it's written at most K stops. And if there is no such route, return -1. So what question is saying that we have given a source, a destination. So we have to return the cost to reach from source to destination. So to reach from source to destination, either we can take a direct flight, or we can stop at one place and then take a flight from that place, or we can stop at two places and then reach the destination. So like this, we can take at most K stops and then reach the destination. So out of all the possibility, we have to find out which path is giving us the minimum cost. So we have to return that. And also, there might be a case that there is no way to reach from source to destination. In that case, we have to return -1. That means there is no connectivity from source to destination. No connectivity from source to destination. Let's take one example. Suppose there is a city, Ahmedabad, Bangalore, and Calcutta. And there is a flight from Ahmedabad to Bangalore, and the cost of the flight is 400. There is a flight from Ahmedabad to Calcutta, and the cost of the flight is 100. And again, there is a flight from Calcutta to Bangalore, and the cost of the flight is, let's suppose, 200. Now, if we have asked what is the price, cheapest price to reach from Ahmedabad to Bangalore, then first we have to see what is the K value. K value indicates how many stops we can take. Suppose K value is 0, that means we can't take any stops. We have to reach directly from Ahmedabad to Bangalore. If K is 0, that means we can't take any stops. So that in that case, we have only one option, that is Ahmedabad to Bangalore with cost price at 400. So in that case, our cost will be 400. Now suppose K given is 1. That means we can take at most one stops. At most one stops. It's not necessary that we have to take one stop. So in that case, we will see we have two options. Either we can take a direct flight, that is K equal to 0, or we can take a one stop flight, that is K equal to 1. So in case of K equal to 0, we have only one option, that is Ahmedabad to Bangalore with cost price of 400, right? Now for K equal to 1, that means we can take one stop and then reach Bangalore. So again, we have only one options from Ahmedabad to Calcutta and then Calcutta to Bangalore. In that case, the cost will be 300. So now we have to see which one is giving us the minimum. So we can see if we take a one stop flight, then cost will be minimum. So the answer for this will be 300. That means we can reach from Ahmedabad to Bangalore with a minimum cost of 300. And there can be a case like if someone asks, what is the cost to reach from Calcutta to Ahmedabad? And so in that case, suppose if k given 0, we have to see, that means we have to check by taking one flight, what is the minimum cost to reach from Calcutta to Ahmedabad? So from Calcutta to Ahmedabad, we can see taking one flight, we can't reach Ahmedabad. So taking one flight, we can only reach Bangalore. If k equal to 0, that means we don't have a direct flight. That means in that case, we can't reach Ahmedabad. So we have to return -1. Now suppose we are given k equal to 1. So we have already seen for k equal to 0, we can't reach. Now we will see by taking at most one stops can we reach to Ahmedabad or not. So from Calcutta, we can see we can only reach Bangalore. And from Bangalore, we can't take any flights. We can't reach anywhere. That means even if we take a one stop flight, we can't reach Ahmedabad. So in that case also we are getting -1. So in this the result will be -1. Now suppose we take one more example. We have Calcutta, we have Ahmedabad, and we have Bombay. Now suppose from Calcutta to Ahmedabad, we have a flight and the cost is 100. From Calcutta to Bombay, we have a flight and the cost is 200. And from Bombay to Ahmedabad, we have a flight and the cost is 300. And from Ahmedabad, Calcutta, we have a flight and the cost is 300. Now, if someone asks me, what is the cost to reach from Bombay to Calcutta? And K value given is 0. In that case, we will see k equal to 0 means we can take at most k plus 1 flights. So here k equal to 0, that means we can take at most one flight. So taking one flight from Bombay, we can reach only Ahmedabad. So we can't reach Calcutta. So in that case, our answer will be -1. Now suppose k value is 1. That means we can take at most k plus 1 flight. That is 2 flights to reach Calcutta. So from Bombay, we will see where all places we can reach. So we can reach only Ahmedabad. So taking one flight, we can reach Ahmedabad. Okay. And the cost is 300. Now from Ahmedabad, we will see in where all places we can reach. So we can reach only Calcutta. So in that case, the cost is 300. So since we are allowed to take two flights, so by taking two flights, we can reach from Bombay to Calcutta. So in that case, our answer will be 600. So that's what question is saying. So we have to return this value. Now let's take this given example and reach the solution. Suppose we have this example. In this example, the n equal to 4, that means we have 4 cities. Flights given like from city 0 to city 1, we can reach at price 100. City 1 to 2, we can reach at price 100. City 2 to 0, we can reach at price 100. And city 1 to 3, we can reach at price 600. And city 2 to 3, we can reach at price 200. And the source given is 0 and the destination given is 3. And the k value is 1. That means if k value is 1, that means we can take at most k plus 1 flights, right? So what we will do, first we will draw one table. So we have 4 cities. So in a column, we will keep the cities. That means we have 4 cities. And in rows, we will keep the number of flights we can take. 0 flights, 1 flight. Suppose, so this column indicates the city number and row indicates the number of flights taken to reach that city. Now we will give a numbering. So this is city 0, city 1, city 2, city 3. And the flights, this indicates 0 flights taken, 1 flight taken, 2 flights taken, 3 flights taken. So initially, we are at source and we have not taken any flights till now. So at source is 0. That means we are at 0 city. We are at city number 0. So the cost to reach at city number 0 is 0. And other places it is infinity. That means we can't reach, taking 0 flights, we can't reach these cities. Now suppose, so since k value is 1 and we are, that means we are allowed to take at most 2 flights, at most 2 flights, right? If we take 1 flight and we are at city 0, so we will see in which all places we can reach. From city 0, we can see we can take only 1 flight and we can reach only at city number 1. So to reach city number 1 from city number 0, what will be the cost? The cost to reach at city number 0 and the flight cost which we are taking from city number 0 to 1, that is 100. So to reach 1, taking 1 flight, the cost will be 0 plus 100. That is 100, right? So we will see, can we reach any else anywhere in other cities from city number 0? So from this given flights, we can't reach. So from 0, we can only reach at flight city number 1. Now, since we are saying we have taken a one flight, we have already taken one flight. So after taking one flight, what are the places we can reach? If we have taken one flight, we can reach only one. That means to reach city 0 after taking one flight is infinity. This is also infinity. This is infinity. Now we will see after taking one flight in which all cities we can land. And from there, we will explore. We will take one more flight and see in which all cities we can reach. So after taking one flight, we have only one options, that is city 1. Now we will see from city 1 in which all places we can reach. From city 1, we can see we have two options. Either we can go to city number 2 or we can reach city number 3. So if we go city number 2, what will be the cost to reach city number 2? So to reach city number 2, the cost will be cost to reach city number 1 and the cost of the flight from city number 1 to 2. That is 100 plus 100. That is 200. And from city number 1 to 3, what will be the cost? The cost to reach city number 1 and the flight cost to take from city number 1 to 3, that is 100 plus 600, that is 700. So now can we say after taking two flights, we can reach only to city number 2 and 3. If we have necessarily taken two flights, then we can reach only city number 2 and 3 if we have started from destination source 0. That means we can't reach 2, we can't reach 1. Now from 2 to 3, we will see which all places we can reach. So from 2 we will see we can reach 3 and 0. So from 2 we can reach 3 and 0. So to reach 3, what will be the cost? So the cost to reach 2 plus the flight cost to take from 2 to 3, that is 200 plus 200, that is 400. And to reach 0, the cost will be 200 plus 100, that is 300. So that was from city number 2. Now from city number 3, so from city number 3, we don't have any flight. That means we can't go anywhere else. That means after taking three flights, we can reach only city number 0 and city number 3. That is, we can't reach 1 and 2 if we have necessarily taken three flights. So this row indicates if we have taken 0 flights, we can reach only at city number 0. If we have taken one flight, we can reach only city number 1. If we have taken two flights, we can reach only city number 2 and city number 3. And if we have taken three flights, we can reach city number 0 and city number 3. So this was like what row is indicating. Now, if we see a column wise, so what column 0 is indicating that from city number 0, that we can reach city number 0. This row will indicate what are the prices to reach city number 0 if this we have taken this many flights. Now, so in the question, the K value was 1. That means we can take at most two flights. At most two flights. That means this option is valid. This option is valid. This option is valid. Since here we are taking two flights, but this option is not valid because this row indicates we can reach the cities after taking three flights, but we are not allowed to take three flights. So we will see only in this first three row. So what is the destination? Destination is three. So we will go to three and we will see whether we can reach the destination 3 anytime after taking either zero flights, one flights, or two flights. So we can see after taking zero flights we can't reach, but after taking one flight also we can't reach, but after taking two flights we can definitely reach three, and the cost to reach is 700. So the answer will be 700. Now suppose there would have been any flights which made it possible to reach city number 3 after taking one flight also, and the cost to reach city number 3 after taking one flight, if it was 400 suppose, then in that case we have to check, and being a destination 3 we have to see, can we reach destination number 3 by taking after zero flights, one flights, or two flights? So we can see after taking two flights also we can reach destination number 3, and after taking one flight also we can reach destination number 3, and after taking two flight also we can reach destination number 2. So out of this we will see what will be the minimum to reach. So minimum to reach city number 3, the cost will be 400. Now since Now suppose if the k value would have been 2, not 1. So in that case, we would have taken at most 3 flights. So in that case, in that case, this row would have been also valid. So we will see to reach city number 3, what are the possible ways. So by taking zero flights, we can't reach. By taking one flight, we can reach at cost 400. By taking two flights, we can reach at cost 700. And by taking three flights also, we can reach at cost 400. So in that case, we will take the minimum of this row. Minimum of this row. And if there has been a case that there is no flight, in that case, all this row would have been infinity, and we would have written infinity. That means we don't have any flights. In that case, we would have written -1. I hope I have explained the solution. Let's take one more example. So this is a small example. Let's take this example. So since we have three flights and the k value given as 1, that means we can take at most two flights. So since column indicates the city number, so we have three cities, 0, 1, 2. We will write 0, 1, 2. And since k value given is 1, that means we can take at most k plus 1 flights, that is 2 flights. So we can indicate 0 flights, 1 flights, 2 flights. And source given is 0, and destination given is 2. So since source is 0, so without taking any flight, we can reach at source 0, at cost 0, and city 1, the cost will be infinity, and city 2 also cost will be infinity. Now, after taking one flight, we will see in which all cities we can reach up from city number 0. So we can see we have two options. Either we can go to city number 1 or we can go to city number 2. So if we go to city number 1, the cost to reach city number 1 will be 0 plus 100. That is 100. And to reach city number 2, the cost will be 0 plus 500. that is 500. So that means if we have mandatorily taken one flight, that we can only reach city number 1, city number 2, but we can't reach city number 0. So in that case, it will be infinity. Now, suppose from city number 1, we have taken one more flight. So we will see in which all cities we can reach. So from city number 1, if we take a flight, we can go only to city number 2. That is to reach city number 2 from city number 1, the cost will be 100 plus this 100 plus the cost of this flight 100. That is cost will be 200. And to reach from city number 2, we will see we can't take any more flights. That means after taking two flights necessarily, we can only reach to city number 2 and not city number 0, not city number 1. So it will be infinity. Now, since we are asked the destination is 2, so we will see the column number 2 and see can we reach city number 2 anytime after taking any of these flights, either one flight, two flights, or zero flights. So we can see we can reach city number 2 after taking one flight also, after taking two flights also. So what is the minimum to reach here? So to minimum to reach city number 2, so minimum will be minimum of 500 and 200. So minimum is 200. So the answer will be 200. That means to reach city numbers 2 from city number 1, the cost will be 200. So that's the answer. Now suppose I want to take one scenario. Now suppose there is a scenario. Suppose this is city number 0, 1, 2, and we can reach city number 2 after taking one flight is the cost is 200, and to reach city number 2 after taking one flight the cost is 300. Now suppose there is a flight from city number 2 to 1 and also a flight from city number 2 to 1. And the cost of this flight is 50 and the cost of this flight is 200. So, by what value we will reach? By what value we will update this cost? Since after taking two flights, we can reach to city number 1 from two ways, either one from city number 0 to city number 1 or from city number 2 to city number 1. So in that case, we will take the minimum to reach here. That means we are already taking two flights, right? So after taking two flights, we will take the minimum of this cost. That means minimum of 200 plus 300, comma 300 plus 50. That is, we will update this position with rupees 350. So if we have multiple options to reach any cities by taking any number of flights, we will update with the minimum value, right? There is no sense of updating with 350, 500 because this cell is saying that to reach city number 1 from a source, suppose source was 0. So this cell will indicate to reach city number 1 from a source 0. After taking two flights mandatorily, we can reach with a minimum cost of rupees 350. So that was the point I want to make it clear. So what we are doing? So let's see the time complexity if we write an algorithm for this. So what we are doing, suppose, so after every flight, we are updating what are the places we can reach from the source. That means for each position, we are updating the next position. Suppose we can suppose at a certain instance we are reached all these cities. We can reach all these cities. Now, if we want to update the next instance, like after taking one flight, what are the cities we can reach? So what all we have to check. So from city number 0, we have to check if there is a flight to city number 0, if there is a flight to city number 1, if there is a flight to city number 2. That means for each position, we have to check n cities. So if there are n cities, we have to check n square cities, right? So every time we are checking n square cities for each flight. And if there is k plus 1 flights possible, then we have to check k plus 1 into n square. So this many operations we have to perform. So time complexity for this algorithm will be big O of k into n square. And since we can see the k value given is less than n. So if this is maximum n, that means we have to perform n cube operation. So, and we can see the value of n is maximum 100. That means it will take a maximum of 10 to the power 6 time complexity. That means we can perform this algorithm. So one more thing I want to make it clear, like the information given to us about the flight is in a vector. It is not like what we are seeing in a graph. So before that, we can convert the given information into a graph and then we can perform these operations. So let's write the code. First, we will create a map which will store this information. And the graph size will be n. Since there are n cities, so we'll create n nodes to it. Now, we will iterate the flights vector and update the graph of IT of 0, that is source. From source, we can reach destination, and destination given as IT of 1, and the cost to reach is IT of 2. So we have created the graph. Now what I have said, like how many flights we can take. Let's write fly. So it is k plus 1 fly. So we can fly k plus 1 times. So to draw that table, we have to create a 2D vector. Let's write this at route. And since we can take at most FLY, that is k plus 1 flights, so to make fly plus 2 or fly plus 1, comma, vector of end. And initially, since to reach any cities will be infinity unless we update that cell, so we will use int max and the number of columns is the city number. So this is the table we have drawn. Now we will update this table one by one. So initially we can see if the source is given, that means to reach a route that is source at zero flight, means without taking any flight, we can reach this only source with cost zero. So we will update. Now for each flight that is from flight 1, that is from after taking flight 1, that is from 0 to fly so for each flight we will iterate like, so this will indicate, this loop is indicating like, suppose we are at position number 0 without taking, so suppose now we take one flight, so we will reach at position number 1. So we will update this cells. So since our fly value will indicate how many flights we can take, so we will iterate flight times. And for each flights, we will update the city's values, whether we can reach that city or not. And the city count is n. Now we will see if we have already reached that cities or not. So if we have reached that city, then this int max value would have been updated. That means we can compare it with int max. If I, that means current city, and after taking current flight, that is 0, I, if it is not equal to int max, that means we have reached the city. Now we will explore the flights we can take from city number I. So we will iterate ID. So from the graph, we can iterate the flights we can take from city number I. From city number I, and in what we have decided, like we will update only if the existing value is maximum than the current cost. That means we will check if if current cost, that is I plus 1, IT of 0 is greater than route greater than current flight cost I j plus IT of 1. In that case, we will update it. This is the case, we will update it. Else we will not. Now, after updating all the values, we will see whether we can reach the destination or not. So let's suppose the cost is int max. So we will see the we will run a for loop for that column, that is the destination column, for the whole flight from I equal to 0 till I equal to I less than equal to fly I plus plus, and we will see whether we can reach that destination by taking any number of flights or not. Suppose if the route and the flight is I and the column is destination, DST, destination. If it is not equal to int max, that means we would have reached that destination after taking I number of flights. So in that case, we will update this cost value with the minimum of cost and the current cost, that is out of I and TST. Now we will see. So we have already updated with the cost variable. Now after updating, still the cost value is int max. That means we can never reach that destination. In that case, we will return -1, else we will return cost. Now let's see what we have done. So in this, since we can take k flights, that means k stops, that means we can take k plus 1 flight. If it is k plus 1, that means if k value is 2, we can take 3 flights. So 3 flights. So we have to create a dimension of 0, 1, 2, 3. That means either we can take 0 flights, 1 flights, 2 flights, and 3 flights. If the k value is 2. So we have kept this value in fly, and we have created a dimension of fly plus 1. So initially we will be at position number 0. We will check whether from source to destination we can reach after taking 1 flight. So after taking 1 flight, our value will increment to 1. After taking 2 flights, our I will increment to 2. And after taking 3 flights, our I will increment to 3. Right? And then after updating this table, we will find the minimum to reach that city. So that will be the cost. Let's try to run this solution. So since we can see our test case has been accepted, now let's try to submit all the test cases. So our solution is accepted. And we can see the time complexity of this solution will be fly into n into the neighbor of this node, and the neighbor can be at most n. That is, and fly value we have seen it is k plus 1. And k value also we have seen from the constant, it is can be at most n. That means the time complexity is n into n into n. That is O of n cube. I hope I've explained the solution. Meet you in the next video. Thank you.